Welcome one and all. So in this video I'm going to concentrate on the nucleophilic addition type of reactions. So addition reactions means everyone is having an idea about the carbon-carbon chemistry. Here we are going to discuss about the carbon oxygen type of chemistry in which there will be a nucleophilic addition reactions are experienced. For example, there will be a hydrate addition, sodium borohydrate or lithium aluminum hydrate added to the carbon oxygen bond. And similarly, cyano addition. So cyanide group is going to attack the carbon oxygen bond. Similarly, we have another example that the Grignard reaction is a quite familiar example for our nucleophilic addition reactions. So in this video, I am going to concentrate on fully about the Grignard reactions. So he is our Francis August Victor Grignard. He is known for Grignard reagent. So Grignard reagent is nothing but a organometallic chemical reactions in which alkyl or allyl or vinyl or aryl magnesium halides. So which is added to the carbonyl group, that is our aldehyde or ketone, to give a corresponding alcohol as a product. For his great contribution, he has received his Nobel Prize for chemistry in the year 1912. His advisor, that is a doctoral advisor, Philip Barberier, who is known for the Barberier reactions and organomagnesium reagent. So I have given you the Barberier reaction as well as the Grignard reactions here. So Barberier reaction is simply involved in the case of our carbonyl compound along with our carbon-carbon double bond. What he has prepared, that reagent is attacking only a carbon oxygen chemistry only, not a carbon-carbon bond. So in this carbon oxygen bond is the methyl iodide and magnesium along with our ether. He is going to use 12 hours reaction with a 31% of product, and there he is mentioning about that it is not following under the reaction with the Zeistow conditions. And simply you are getting a alcohol as a product. So the Barberier reported this in the year 1899, and Grignard was published first in this particular area about the change in the polarity of this one, our carbon oxygen bond. See that his first publication to use as a Grignard reagent in the year 1900. Yeah, carbonyl compound here, a ketone you are going to take here, carbonyl compound, and methyl magnesium iodide with ether. He has achieved with a 51% of the product, and he is getting a alcohol as a product. So this is the particular reaction is known as Grignard reaction, was published the reaction in 1900, and prolonged usage and more number of work on this and his great achievements has received in the Nobel Prize the year 1912. So this is another example here. Grignard reaction is a carbon-carbon bond forming reaction by which almost any alcohol may be formed from the appropriate alkyl halides and carbonyl compound. If you use the carbonyl compound and alkyl halides and you are preparing a metallic magnesium as well as the ether, that will in turn give you a organometallic reagent is prepared. That is our Grignard reagent. And for example here, to synthesize the alcohol, that is our triphenyl methanol via Grignard reaction. So alkyl halide is used. Initially the reaction is treated with a magnesium and ether. So here the reaction must be concentrated with our ether, not with water. Okay, and there must be a dry condition because already we are well known about the magnesium. Magnesium is very dangerous to use with the presence of our water. So there will be hazardous reactions may be experienced, so that we must have a dry conditions of the ether. Dry ether must be used, and once you use the magnesium and ether, what will happen that alkyl halide is converted as a alkyl magnesium bromide. That alkyl magnesium bromide is going to attack the carbonyl compound, followed by the acid workup or hydrolysis in the presence of hydrochloric acid, that will in turn give you a alcohol as a product. So you are getting a triphenyl methanol. If it is CH3OH, it is a methanol. It is a phenyl group is there, so the triphenyl methanol as a product. And this is the explanation about the previous slide here. Triphenyl methanol is prepared from the benzophenone using a Grignard reagent, that is phenyl magnesium bromide, through nucleophilic addition mechanism. So magnesium alkoxide is formed as an intermediate which is hydrolyzed, use the hydrochloric acid to form a ether soluble product, that is ether soluble triphenyl methanol, and a water soluble salt like our chlorobromo magnesium. So once it is formed, we can separate it. We are all well known about the separation chemistry. So the ether soluble component as well as the water soluble component can be separated, and we are getting the product exclusively about our triphenyl methanol as a product, which comes as a 51% of the product. The Grignard reagent, what are the things, important aspects is present in the case of Grignard reagent? So Grignard reagent can be viewed as an ionic species, so that there will be a formation of carbon ion or minus. That's why the initially what we in the alkyl halides, alkyl halides means alkyl bromide, alkyl chloride, anything. In this case, carbocation may be there. Okay, CH3 plus and Cl minus, CH3 plus Br minus. Whereas the magnesium is introduced along with the ether. What will happen? The alkyl halide having a CH3Br, in between there will be a insertion of our magnesium come over here, so that the Mg2 plus is coming over there, and carbon ion and our bromide ion is acting as a ionic species, which is forming a methyl magnesium bromide or alkyl magnesium bromide. So in such a way that the formation of the alkyl group, that the alkyl carbon is there, that convert the polarity into delta positive to delta negative sign here, so that once the carbon ion is formed, carbon ion is an highly extremely basic, as well as it is worked as a nucleophile. So this nucleophile is going to attack the electrophile, that is nothing but our carbonyl compound, so that we are getting a experienced product like our followed by the acid workup or hydrolysis will result into the alcohol as a product. The ketone intermediate reacts with a more Grignard reagent, leading to the formation of highly substituted alcohol. So this is the explanation about the mechanism. Grignard reaction allows the formation of carbon-carbon bond using a organometallic intermediate, which is nothing but our Grignard reagent, that is methyl magnesium bromide or phenyl magnesium bromide. Simply alkyl magnesium halide, because in so many papers the people are reporting about the methyl magnesium iodide. Some people they are reported about methyl magnesium bromide. Somebody reported with the halides like that. So we are simply say that general name with the alkyl or aryl magnesium halides. So Grignard reagents are prepared by the reacting with magnesium metal with alkyl or aryl halides in a aprotic solvent such as our ether, diethyl ether or tetrahydrofuran. And they have a carbon metal bond here, which changes the polarity of the carbon from the partial positive charge, which is present in the aryl or alkyl halides, which has transformed into the partial negative charge using our Grignard reagent. So that based on this particular effect, what will happen? The carbon ion, once it is formed, act as a strong nucleophile and which can attack the electrophilic species like our carbonyl compound. So in the presence of acidic condition, acidic protons like our water is there or alcohol is there, the Grignard reagent is totally breaks or fails, and leading to the formation of our hydrocarbon instead of our wanted alcohol, so that the reaction must be carried out in a dry conditions only, not in a wet conditions. As already I mentioned you about that, if there is a humidity is present or water is present or alcohol is present, what will happen? The magnesium can react with that. In such cases, there will be explosion will takes place. So that we must maintain the condition like a dry condition, so that the Grignard reactions worked well with only in dry conditions to get our expected product. So the mechanism is explained here. I have already mentioned about the, if there is a humidity, the carbon ion which has formed during the help of our Grignard reagent can be converted with our hydrocarbon. Whereas in the case of our dry conditions, what will happen? The formed carbon ion is going to attack the aldehyde. So that what will happen? This nucleophile is going to added here. So that it is called nucleophilic addition. So that the carbon ion is going to add here, followed by the hydrolysis process will result into the alcohol. Similarly, in the case of our aldehyde, we are getting a secondary alcohol. If you are using a ketone or ester, you are getting with a tertiary alcohol as a product. So all the cases, what we are going to have a idea on that. If you are using a aldehyde, definitely secondary alcohol as a product. If you use ketone or ester, our carbon ion is going to add and form a nucleophilic addition in all the cases in the carbonyl compound, whereas the followed by the hydrolysis will give you a secondary alcohol for aldehyde, tertiary alcohol for ketone or ester if you are used. So that what I am trying to explain, that the Grignard reagent reactions are worked only in a dry conditions only, and the preparation of the reagent as well as the acid workup is very highly important, highly sensitive one, so that these sensitive reactions will give you a alcohol as an product, exclusive product. So that this is the Grignard reactions and the nucleophilic addition reaction that I am going to try to explain you in this video. Thanks for watching this video. Like it and subscribe it and share it for more number of videos. Thank you.